Measuring the experimental value of the resistance, we'll prepare circuit 1, 3 resistors in series, and circuit 2, 3 resistors in parallel. So circuit 1, 3 resistors in series using the electrical circuit board. So this is R1 connected in series to R2 connected to R3. And also in this lab, instead of using a battery, we'll use a power supply. So we have a direct signal, DC signal. We fix our voltage at 5 volts. This will be V total. Now we will measure V1, V2, and V3, and V equivalent of R1, R2, R2, R3, and R1, R2, and R3. This is a series circuit. So V1 plus V2 plus V3 should be equal to V total, to 5 volts. Okay, the voltmeter, to measure the voltage, the voltmeter should be connected in parallel. So we will connect the voltmeter in parallel to R1. So V1, it's 1.10 volts. The smallest digit, it's 0.01 volts. So it's 1.10 plus or minus 0.01 volts. So 1.10 plus or minus 0.01 volts. Now for R2, also it should be connected in parallel, so it's 1.66 plus or minus 0.01 volts. Now R3, if you look at the multimeter, we have a negative sign. The negative sign, it's because we are branching the voltmeter in the opposite direction of the current. So the plus is on the minus and the minus on the plus. So we switch the leads. So now the COM is connected to the minus, the plus is connected to the plus. So V3 it's 2.69 plus or minus 0.01 volts. Now R12, so we're measuring V of R1 plus R2. So it should be connected in parallel to R1 and R2. 3.04 plus or minus 0.01 volts. V23, so in parallel to R2 and R3, so 4.52 plus or minus 0.01 volts. V123, it should be equal to V total, so because it's V1 plus V2 plus V3. It's a series circuit, so it's 5.74 plus or minus 0.01 volts. We have a percentage difference between the expected value, it's 5.5, and the obtained value. You need to think about your sources of error, the wires, the multimeter, the power supply, the circuit board, the resistance. Okay, now we need to measure the current. To measure the current, we need to connect the multimeter, the ammeter, in series. So we'll be using this ammeter, V and become, the ammeter should be connected in series. It's a series circuit, so the current should be the same, but we will verify if we have a constant current. So V0, it's 1.2 milliampere. Plus or minus 0.1 milliampere. Now, I1, the current through the resistor, it's 1.1, 1.2 plus or minus 0.1 milliampere. It's fluctuating between 1.1 and 1.2. Now, I2 will disconnect R2 and we will add in series the ammeter. So I2, it's also 1.2, it's 1.1 plus or minus 0.1 milliampere, and I3 it's minus, because we are, okay, so it's minus 1.1. Okay, so we need to switch the connection. So it's 1.2 milliampere. So now we will repeat the same procedure but with a parallel circuit. So we'll turn everything off. We'll take the 3 resistors, okay, and we will connect them in parallel. So R1, R2, and R3, we need these leads wires. Now R1 and R2, they are connected in parallel. Parallel to R3. Okay, we need to close our circuit. We have already measured our equivalent. Now we need to measure V. It's a parallel circuit, so V1 should be equal to V2, should be equal to V3, should be equal to V total. But we will verify our values. So V total, it's 5.5 volts. V1 is 5.73 volts plus or minus 0.01 volts. V2 is 5.73 volts, and V3 it's 5.73 volts. Okay, now we need to measure the current through each branch. So we will start with I0, then I1, I2, and I3. So to measure I0. We will remove this wire and we will connect the ammeter in series. So I0 is 12.0 plus or minus 0.1 milliamperes. We will disconnect it. We will close the circuit again. Now we need to measure I1. So in the first branch, we will connect the ammeter in series with I1. So it's 5.6 plus or minus 0.1 milliamperes. Now the same procedure with I2. We disconnect I2, we'll add the ammeter in series. So our I2 it's 3.8 milliampere. I3 2.5 milliampere. Now I4 12.0 milliampere. So if we add I1, I2 and I3, 5.6 plus 3.8 plus 2.5, it should be a value around 12 milliamperes. You will use these values to prove, to verify Ohm's law. You will take two examples from the table with V equals Ri. The percentage, you will calculate the percentage difference because you have an expected value, let's say, and a calculated one. Then you will think about your sources of error.